Okay, so welcome to this video. We're going to be doing number 16 and 17 on your worksheet. So let's just go ahead and get started. This is very, very similar to the last one. I'm going to do just a couple of things different, but not much, just to show you a different method for computing the molarity as a review. But let's just go ahead and get started. If we have, so we have 2 milliliters, and it is just 2, of a 0.2 molar sodium hydroxide, and we're going to mix it with 1,000 milliliters of a 0.1 molar calcium chloride. And the question is, will calcium hydroxide that is produced in this reaction form a precipitate? So again, guys, remember we have a mixture here of sodium hydroxide, and we're going to mix that with calcium chloride. And so when we put these together, I'm going to draw this larger, because in here we now have the Na and we have the OHs, we have the calcium, and we have the chlorines all floating around in solution. And no, I did not make those in correct proportion to each other, but this is what we have. So again, we're starting with 2 milliliters, and this one is 1,000 milliliters. So remember, this is 0.2 milliliters when we put the two together. So again, you could go through and write your entire reaction that you're having on there. Is it 100% necessary? No, because they do tell us already that we're wanting to check whether or not it is the calcium hydroxide that precipitates out. But I am going to go ahead, because I don't think it hurts us to remember how we write our double replacements. So again, what we're looking for, and the question is will this actually precipitate? Or are we still going to get an aqueous solution? So even though I put an S there, that is a question. That's what we're looking for. So since we're looking for this as a solid, we're wanting to know, is that going to stay in solid form, or will it in fact break into its ions and stay separate? So remember, we're going to find our Q value and then compare that to our K value. Now, one thing that I did notice a couple of you are doing on a worksheet, quiz, whatever it was, on there, is you're not writing what this is equal to. And since we do have multiple K's and Q's, you do need to state whether it is KSP, QSP, KC, QC, what it is here that we are finding. Okay, and again, it is going to be our Q for our solubility. So again, this is calcium. We've got our hydroxide, and we've got 2 of those, so we have that squared. So far, this is just my basic information that I know without doing any real work per se. So now let's go back to what we have, because what we need to know is what is the calcium molarity and the hydroxide molarity. Now remember, it is not the molarity here or here. It is what now molarity would it be over here to determine whether or not it precipitates out. But we're only given the molarity over here. So we are going to have to start with that piece of it. And so for this first one, we have 2 milliliters. That is a 0.2 molar solution. And so what we want to know is, what is the molarity of the hydroxide in this one from this information. And the last time I set it up as kind of a proportion, and this is still somewhat of a proportion, but if you will remember, earlier on we did solution where we did M1 V1 equals M2 V2. And since I'm just taking this solution and I'm somewhat upgrading it to an 1,000, we could just use this one. It's going to work out the same way. So we're going to have a 0.200 molar. And my volume here, I'm going to go ahead and change it to liters. So that's a 3 decimal places over. So be sure you do change that correctly. I want to know my new molarity when it is 1 liter. So the part that makes this nice is it is just a 1. Here's my multiplication. And so I would just need to put that into the calculator to see what it is. And that would be 4.0 times 10 to the negative 4 molar. And again, that is this one is for my hydroxide in this solution. Okay, so we're going to now go to this solution, and it tells me that I already have a 1 liter solution. Therefore, I don't need to do anything to this one. I know that my calcium is a 0.1 molar. And again, because it is a 1:2 ratio here. So back that up. This is a 1:1 calcium to calcium chloride. This would be a 2 chlorine to 1 calcium chloride. So since calcium is just a 1:1, I can just use that number. I don't need to do any calculation. Now again, going back to what I said earlier, this hydroxide is the molarity of this solution. This calcium is the molarity it is in this solution. Now I'm putting both of those into this solution, and now I need to calculate a new molarity on there, because again we've somewhat diluted it down possibly by putting it into a larger beaker of water there, if you want to think of it that way. So in order to do that, what we're going to actually be calculating is the concentration of my calcium hydroxide. Okay, and to do that, we want the molarity of my hydroxide times my molarity of my calcium. And again, we're still somewhat using that formula up there, divided by my total, which is now 1,002 liters. So move your decimal over. Okay, and run those numbers. And I got, and you probably need to check my math all the time to make sure I'm right, but I got 3.99 times 10 to the negative 5 molar. Now, again, since calcium, there is 1 calcium per calcium hydroxide, this becomes also my calcium's molarity. But hydroxide is a 2:1, so my hydroxide molarity is twice this. Okay, and again, check my math, but I got, let's see what I got, 9.998.1 times to the negative 2. Now, let me make another comment here on that. And what I'm seeing is a lot of you guys are trying to do a lot of rounding. And yes, you can do some rounding because obviously some of these numbers continue on, and I did do some rounding. But it is better to always hang on to more than you need and worry about the final significant digits at the end. So when I'm looking at this, this is 3, because all of those count, 3. I've got 4 actually here because of that decimal point, and I have 3 here. I've got 3 here. So the minimum you would round to the 3. So I could have gone up to 1.00 and brought this down 1, but I'm going to hang on to numbers. So it's better to hang on than to round too soon, okay? So these are my 2 molarities that I need. Now I have the information to put into my QSP. So calcium was 3.99 times 10 to the negative 5. Hydroxide is 9.998 times 10 to the negative 2. And you know what I just noticed on my paper, so we're going to check my math. This is squared, and I don't know that I squared it when I ran it in my calculator. So let me go ahead and put that in. So, okay, again, please double check all the time my numbers, but again, this is not what I had earlier because I realized as I was copying things down that I did not square this originally. So this is what I get, 3.99 times 10 to the negative 7. I notice it's not going to affect my overall answer, so I think we're good. So now what we're going to do is we are going to compare our K value to this value. And since this is negative 7, that's a negative 6. That means that my QSP is less than my KSP. And again, I like writing down my numbers also to show that, because I know that number is less than this number. And remember, if your QSP is less than your KSP, you will have no precipitate formed, which is my final answer. Okay, so this does require quite a bit of work on that, and I think to me the key is not this piece, because I think we've got this down. It is over here just realizing that you're given molarity here, you're given molarity here, but you're taking both of these and putting them into a beaker together, and therefore we must compute their new molarities. Okay, so have fun with that. Let me know if you have any questions.